Okay, welcome back. Whatever two numbers you picked, they always had to add up to 10, right? If you pick 5 and 5, those add up to 10, and then 10 times 2 is 20. Or if you picked I don't know, 9 and 1, right? Those add up to 10, and then double it, you get 20. So you probably noticed pretty quickly that after a couple of tries, you're always finding two numbers that add up to 10. Okay, so we can kind of simplify this in saying, well, our two numbers x plus y have to be 10, right? So that is one way that we can think about simplifying this problem, is that the 2 doesn't really matter, right? Because I could divide both sides by 2, and I get 10 on that side, right? And you would find out that the same issue comes up with this one, that 3 times, I don't know, 15 minus 5 is equal to 30. That these two numbers always have to subtract to 10. So you could simplify this process and say, well, the two numbers have to subtract to 10, right? So what two numbers add to 10, and also when I subtract them, it's 10? Well, I can make a guess and see how far I am apart. So how about 9 plus 1 is 10? And then 9 minus 1 is 8. So that did not work. So this number needs to get bigger, or this number needs to get smaller, right? So how about I go to 10 minus 0, right? So 10 minus 0, the difference between those two numbers is 10, so that works. Now let's see, 10 plus 0 is also 10, so that works. So it's true for both at the same time. So that's my solution to this kind of problem, is to say that if the first number is 10 and the second number is 0, then it works. And we will go about solving these types of things. They're called systems of equations. So you can really write this as a system of equations, that x plus y equals 10 and x minus y equals 10. So we write it like this with a little curly brace, and they both have to be true at the same time. So that's what we're talking about in this section, is solving these systems of equations where they have to make both equations true.